Hello, this video is for Learning Intention 29 and we are looking at discrete random variables and discrete probability distributions. Lots of words. I have purposely restricted myself here to one page because this area of maths is absolutely fascinating. It blows me away and I'm just afraid I'll ramble on forever. So one page is what I'm restricting myself to explain this to you. Alright, variable. Let's start with the word variable. You remember you would have learned several years ago that a variable is like x, right? You got some equation like 4x minus 2 equals 14. And you were told that x is the variable. And you were told you can solve for x. So you go ahead, you add 2 to both sides, you divide both sides by 4, and you get x equals 4. Hey, we've solved for x there. That's great. That's good. That's a variable. All right. What's a random variable then? That's a variable. It has a very fixed value. What's a random variable? A random variable is the outcome of an experiment. It's tied to an experiment. So you do something and then the variable takes on that value. So for a random variable, you do some experiment. It could be flipping a coin, rolling a die, whatever. And out of that experiment pops x. And we usually use a capital letter for a random variable. So over here, the value of the variable was known. Over here, the value is not known. But it is known that it's tied to some experiment. So that's a random variable. What's a discrete random variable? Well, it's when that experiment has discrete outcomes. So remember, discrete means like countable outcomes. So flipping a coin, rolling a die, these are discrete, whereas measuring height or weight or something, those are continuous. So I don't want to go into that too much, but a random variable, the outcome's tied to an experiment. Well, let's look at an example of this. What does this look like? What could the experiment be? Let's define an example. So an example might ask you to display the probability distribution for flipping 3 coins at the same time. And we'll say where x, so this is a random variable, is the number of heads. Alright, lots of information. But now we've tied x to an experiment. The experiment is flipping 3 coins and x is the number of heads. So how do we display this all? Well, we use a table. I'll show you what this looks like. Let's use a table here. Let's draw one up. Alright. So this notation, when I was learning this, it didn't make much sense to me at the start. You start with x up the top, and then you have this funny looking thing. Alright, so you're flipping 3 coins. Well, you could either get 0 heads, you could get 1 head, 2 heads, or 3 heads. Now this thing here, it's saying what's the probability that the random variable is equal to x. In other words, what's the probability it takes on one of these values. So what's the probability of getting 0 heads? What's the probability of getting 1 head? What's the probability of getting 2 heads? What's the probability of getting 3 heads? Let's do a quick tree diagram. Heads, tails, heads, tails, heads, tails, heads, tails, heads, tails, so on. And then you get heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. Alright, so you do your tree diagram. Let's see. Getting no heads. Well, that's that one. That's 1 out of 8. Getting 1 head. Where's 1 head? There's 1 head. There's 1 head. There's 1 head. So that's 3 out of 8. Getting 2 heads. Let's see. Let's use blue this time. 2 heads. There's 2 heads. There's 2 heads. There's 2 heads. 3 out of 8. Getting 3 heads. 1 option left. That's 1 out of 8. Okay, so what? Well, you've just described a probability distribution. This is a discrete probability distribution. And there are 2 kind of big things you need to know about this. So a discrete probability distribution has to abide 2 rules. 1, the sum of probabilities has to equal 1. Well, let's check that. 1/8 plus 3/8 is 4/8, plus 3/8 is 7/8, plus 1/8 is 8/8, which is 1. Beautiful. Rule number 2. All the probabilities must be between 0 and 1. Let's have a look here. Yep, these are all between 0 and 1. So these down here can't be negative. These up here can. These can't. These can't be negative, these probabilities. So for it to be a discrete probability distribution, must follow these rules. So that's a discrete probability distribution. Must follow those rules. So a question might ask, what's the probability? It might say, what's the probability that x is between 1 and 3? In other words, what's the probability that you either get 1 head, 2 heads, or 3 heads? Well, that's easy. You can add the probabilities there. So the probability of 1 head is 3/8, 2 heads, 3/8, 3 heads, 1/8. That's 7 on 8. So that's how you can use the table. You have an interval here. What's the probability that this random variable is between 1 and 3? Well, it's 7/8. Alright, I promised 1 page. Over here, let's look at this example. Oh, that's really important, by the way. Make sure you memorize that. Let's look at this example. Here they're saying solve for k. So you're going to assume that it's a discrete probability distribution, and they're saying solve for k. Well, you know that the sum of probabilities must be 1. So the sum of all these has to be 1. So 5k plus 6k plus 4k plus 3k plus 2k has to equal 1. 5 plus 6, 5k plus 6k is 11k, plus 4k is 15k, plus 3k is 18k, plus 2k is 20k, equals 1, k equals 1 on 20. Beautiful. So we've used one of these properties to find the value of k. Let's look at example 3. Show that the function here is a probability function. Alright, well, what's a probability function? What it's saying is that when we sub in all these values and add up the probabilities, they should add to 1. So let's do that. Let's do p of 2. Well, 2 squared is 4, so that's 4 on 100 times 4, that's 16 on 100. Do this the long way, please. I really want to restrict myself to one page here. P of 3 is 9 on 100 times 3, which is 27 on 100. P of 4 is 32 on 100. P of 5 equals 25 on 100. And we're claiming that if this is to be a probability function, all these should add to 1. So let's check it. Sum of px equals 16 plus 27 plus 32 plus 25 all on 100, which equals, well, 32 plus 27, what's that? It's 59, plus 16, 75 plus 25 is 100. That equals 1. There we are. So I've successfully restricted myself to one page. These are the two most important properties you must take away. For it to be a discrete probability distribution, has to follow these two rules. And a random variable is tied to the outcome of an experiment. So rather than being tied to an equation, you do an experiment and that tells you what the random variable is, which is weird because it's a variable but you don't know the value. It's very strange. It took me years to get my head around this. If you have been, thank you for watching.